Okay, so the first thing we're going to talk about with regular polygons, well, actually any kind of polygons, is polygon names. So this pretty straightforward list. You look at the number of sides a polygon has, and that's the name it correlates to. The only thing I want you guys to pay attention to real quick is some of the names are very similar, like hexagon for 6-sided is very similar to heptagon for 7-sided, so don't get confused on that. And then nonagon for 9-sided is pretty similar to n-gon for anything above 12 sides, although this n, you just replace it with the number of sides. So like if I have a 13-sided shape, I would say 13 gon, or 15-sided shape, I would say 15 gon. I wouldn't necessarily just say n gon. That n is just a placeholder for the number of sides. And then one other thing that's similar is you have decagon for 10-sided, and then for 12-sided you have dodecagon. So just, something to keep in mind. All right, then as far as characteristics, the first characteristic we'll look at is concave. And the main thing to take out of concave, the definition, is that, well, one way that I like to remember it, first of all, it's got the word cave in it, which means it's caving inward in one area. Okay, so you can either remember it that way, concave means caving inward in one area, and then the other thing is that you cannot you can connect two of the vertices on the outside. What that means is for example here, this vertex, if I'm trying to connect it to other points, I can connect it here and here, which that's inside or on the line. Here that's still inside, so that does not meet the definition for concave, but then right here you can connect it outside. Same thing here, you can connect that outside. So this is a concave shape because you can connect 2 points on the outside. Does not mean that you have to do that on every point, right? Like over here, it would not be possible to connect this point to anything on the outside, right? Oh, if we tried to connect to any other point on here, we wouldn't be able to do it on the outside, but it's still a concave shape because over here you can connect on the outside and over here you can connect on the outside. Okay, so that's what concave means, is can connect on the outside, and an easy way to remember is it caves in one particular in at least one place. All right, convex. This might be too much for some of you guys, but I've always remembered convex it has the word vex in it, and I think of a pregnant lady, and a pregnant lady, because of all those hormones, can be vexed. So, bulges outward. Convex bulges outward. But more specifically, if you try to connect two vertices, there's no way to connect it outside of the shape. You're either on the line or you're inside. There's no way to connect it outside the way we did right here. So try to connect. There's no way to connect outside. Right? Every way we try to connect, it's always going to be inside or on the line. Okay? So either you can be like, oh, it doesn't cave in anywhere, therefore it's convex. It bulges out, and it's convex. Or you can be like, the actual definition, you cannot connect any points on the outside. All right, last one, a couple identify things. All right, regular. A regular polygon means that all sides, all right, all sides, all right, all sides are congruent, okay? So we have one tick mark here on this side, then we have one tick mark on every other side, okay? One tick mark, okay? So all sides are congruent. So look for your tick marks for regular polygons. So you're going to look for tick marks. Now, if it's regular, it means all sides are congruent, okay? Irregular means that not all the sides are congruent. So, like, over here, you'll be like, oh, there's tick marks right here, must be regular. Not true, because there's no tick mark on this piece right there. No tick mark on this piece. No tick mark on this piece. Not a regular polygon. Also, on this next shape, you'll be like, oh, but on this one, we've got tick marks all around, so regular polygon, right? Not true, because notice that on these sides right here, we've got 2 tick marks. So these 2 are congruent, but on these sides right here, we've only got 1 tick mark. So that means that this number 2 and this number 1, they're not congruent. All right, so all sides are not the same size. They're not congruent. Okay, so if you're looking for a regular polygon, all sides have to have the same type of tick marks. If it does not have the same type of tick marks, it is an irregular polygon. One other thing I want you guys to notice is all regular polygons are convex. You will not have a concave regular polygon, okay? Irregular polygons can be either concave or convex. All right, moving on to polygon sum. All right, this big bold S over here, that means sum, okay? And specifically, what sum are we talking about? We are talking about the angles inside. So it's interior angle sum. All right, so we're talking about this angle plus that angle. All right, this rule applies whether a polygon is regular or irregular. It does not matter. The only thing that is important, it's got to be convex. Okay, but you can calculate the sum of the interior angles using this formula on any polygon. Does not matter what it looks like as long as it's convex. Okay, so this n right here, that is number of sides. Oops, number of sides. So for example, here, this triangle, it's got 1, 2, 3 sides. We already know that triangles add up to 180 degrees on the inside, but let's go ahead and use this formula and see why. All right, so we've got the sum of the angles on the inside is 180. N is 3, because we've got 3 sides, minus 2. You're gonna be like, where did that 2 come from? Where did the 180 come from? I'm just using the formula right here. Okay, so this is equal to 180 times 1, because 3 minus 2 is 1. And so that means that my sum is equal to 180. Let's try it for a 4-sided shape. 1, 2, 3, 4 sides, right? So sum is equal to 180 times 4 minus 2. I'm just plugging things in where they go. So that's 180 times 2, because 4 minus 2 is 2. So my sum is equal to 360 degrees. All right, moving on. We've got 1, 2, 3, 4, 5 sides. Okay, 180, well, sum is equal to 180 times 5 minus 2. So that means my sum is equal to 180 times 3, because 5 minus 2 is 3. So that means my sum is equal to 540 degrees. This is an S. Okay. Now, you saw me making these markings to say 1, 2, 3. You might be like, oh yeah, I can eyeball it. I know how many sides there are. I would still recommend that you count this way, because it's very easy to accidentally miss something. So it's better to take the time just to count with marking your sides. Okay, so moving on. find the value of x. So the way we would find the value of x on this is we know that the sum of all of these should be, let's see, we've got 1, 2, 3, 4, 5. Oh, we calculated for 5 sides, right? Yeah, the sum of the interior angles for 5 sides is this 540 that we calculated right there, right? So now we know that all of these together need to add up to 540. So let's go add them up and find that missing piece, that x. So I'm just going to start at, let me go ahead and start at x. So I'm going to go ahead and say x plus, and then I'm moving on to this next piece, 122 plus 100 plus 90. Do not forget to add this 90. Draw, actually write in a 90 over there to remind yourself to add it. Okay, plus 144 plus, oh, nothing, we're back to where we started, so we're good there, equals 540. All right, where did I get the 540 from? The sum is 540. We already calculated it. Okay, so now what I need you guys to pay attention to is we've got, this term has an x, and then all of these terms over here have no x. So let's go ahead and combine our like terms. Okay, so what we're going to do is add all of these pink ones in our calculator. So x plus, add them up, we get 456 is equal to 540. All right, now I want x by itself, so I have to subtract that 456 from both sides. That cancels out, and we get x is equal to 84 degrees. All right, moving on. Next shape. We've got 1, 2, 3, 4, 5 sides. So again, we already calculated what the sum of all the angles in a 5-sided shape should be. This one was 5 sides, it was 540. This one was 5 sides, it was 540. So all the angles inside, angles, not sides, all the angles inside should add up to 540. Okay? Now notice that on this shape right here, it's not a regular polygon, but it doesn't matter. We still can use the same formula. Okay? So here we're going to do the same thing. We're just going to add up all these angles and make them equal to 540. I'm going to go ahead and start here with that top 3x. So 3x minus 5 plus x plus 10 plus 4x plus 8 plus 12x. See, I'm just moving this way. Plus 6x plus 7 is equal to 540. So the thing on this particular thing, it's a very long line of things that you're adding up. So let's go ahead and make more sense of it. This has an x in it. This has an x in it. This has an x. That has an x. And that has an x. No x. No x. No x. And no x over here. So every little thing, I know where I'm supposed to add it. All of my yellows, I'm going to go ahead and add them. So 3x plus, now when you're putting this x, don't just say plus 0. There's actually a 1 there, even though it's not like actually written there. So put a 1 there. Yeah. So now you're going to go ahead and calculate 3 plus 1 plus 4 plus 12 plus 6. You get 26x. All right. So now we're going to have to calculate our pink things. Now notice on this pink thing, this is not just a 5, it's a negative 5. So negative 5 plus 10 plus 8 plus 7. And when you add them all together, you get 20. All right. So we get 26x plus 20 equals, and we still have equals 540 on the other side. All right. Now let's try to get that x by itself. So I have to move that 20 to the other side. And we've got 26x, that cancels out, equals 520. Okay, so now I'm still trying to get the x by itself, so I have to divide by 26 on both sides. Okay, and x is equal to 20.